Okay, so let's continue with our next video. And in this video, we will solve the LeetCode database problem. Question number 3482. Analyze organization hierarchy. This is under the hard category, right? So if you want to give a try, click on the SQL schema, copy paste all the statements and execute it locally. So I did the same. Now the data is available. You could see my employees table is available, so that we can like basically uh, give some try on the SQL query or some solution. Okay, so this video might be a little bit long because this is a like a hard category problem, and I am not going to directly jump into the solution. First, I am going to try to solve via naive approach. As an example, if you read the question, what approach should come into the mind and why that approach will not going to work, right? And what will be the solution for that approach? Okay, but let's read the problem. You have just one table given, employees table. You have employee ID, employee name, manager ID, salary, department. Right. So who is the employee? What is the employee ID? Who is the employee name? Who is manager? And what is the salary of employee? And in which department he work? Okay. And there is a hierarchy level. So we need to write a solution to analyze the organization hierarchy. If you see the question, analyze organization hierarchy, and answer the following. Basically, three things we need to figure it out. So write a solution. Solution means write an SQL query. Hierarchy level. For each employee, determine their level on the organization. CO is level 1. So CO is level 1 and under that level 2, under that level 3. So we have this table. So you could see allies. Allies, there is no manager on top of allies. So allies is a CEO. So I just draw one diagram. So allies, there is no manager. So allies is a CEO. So allies is on the level 1. All right. And now Bob and Charlie. Who is the manager of Bob and Charlie? Number one. Now who is the number one? Allies. So Bob and Charlie work under the allies. So Bob and Charlie are on the level 2. So similarly, David and Eva. David Eva works under manager 2. Who is manager 2? Bob. So David and Eva works under manager 2. So David and Eva is under level 3. Alright, and so on. So we need to create a one output column level where we are going to populate. Okay, allies is on level 1. You could see allies is on level 1. Bob and Charlie level 2. Frank, David, and other people 3, and the remaining are on 4. That is one thing. Second thing is team size. For each employee who is a manager, count the total number of employees under them, direct or indirect. So for every employee, for allies, how many number of employee work under allies, how many number of employee work under Bob, how many number of employee work under Judy. Even though no employee work under Judy, no work employee under work under Eva, Grace, Eva, Hank. So, but still, we in the output we need to populate. So for each and every employee, we need to populate the team size. So team size 0, right? For this, and for allies there are 9 people because allies is the top. So 1 2 3 4 5 6 7 8 9 people. All right, so we are going to populate that. The third thing is salary budget. For each manager, calculate the total salary budget they control, sum of salary of the employee under them, and including indirect plus their own salary. So basically, if I have to calculate for each employee how much budget allies control, how much budget Bob control, how much budget Charlie control, so how much budget allies control. So what is the salary of all the employees plus salary of allies? So that is this 12,000. Sorry, 84,500. If you sum up everything, it will become 845. Similarly for Charlie. So how much budget Charlie control? So Charlie control the budget of Frank, Grace, Eva, Judy, plus Charlie itself. So just add this 5 salary and we will get the output. Okay, but these are three things, right? So we can't write a query in a single go. So let's first focus on a one thing at a time. We need to populate a level, and we know level is like this one, 1 2 3 and 4. Okay, and we know if the manager is null, then the level is 1. All right, so if manager is null, then the level is 1. So can we populate one column level with some where clause? uh, I am That is not a solution, but I'm going to tell you what initially come into your mind. So maybe it is coming to your mind, oh, we need to populate a level, so let's populate a level field where manager ID is none. So let's give it try that. So what we will do, let me hide this. So select, we need employee ID, we need employee name, we need manager ID, we need salary. We don't need department, to be honest, because department is nowhere required, neither in this query, neither in this query, neither in this query. So no need to populate a department. And then one as level from employees where manager ID is null. So basically what we are doing is we are populating a level only for those manager, only for those employee whose manager ID is null, basically who are the CEO. So let me execute that. You could see we get the output. Employee ID 1, allies, manager ID, salary 1. We get the output, right? But using this way, we only get the output for allies. So if you see, we get this output 1, allies 1, which is totally fine, right? Which is totally fine. But what about the others? So if you see how you get the level for Bob and Charlie, basically we will just add 1 in the level of allies. And how to get the level of David and Eva? We will add 1. So what we can do is we have this table, right? We have this table, employees table, right? And now we have this table as well. 1 allies 12,001. So now for allies, I know what is the level. For Bob and Charlie, if I want to know the level for Bob and Charlie, what I can do? I can simply join the whole table, employees table, with this CTE. I can put a CTE with this table, right, where manager ID is equal to the employee ID, and put the level field as 1 plus what is the level of their manager, right? Because whatever the level of their manager, employee level is 1 plus that. If the CEO is 1 level, the employees who work directly under that, they are on the level 2. Okay, so we need to join the employees table and the table which we have just created, right? We have just created. So let me create a city with CTES. Okay, so let's join that. Select, so employee ID, employee name, manager ID, salary, and 1 plus level, right? 1 plus level. So we need to add from employees join CTE where. So this is city. We need to check where sit where. Let me show you this manager. Employee table, employee manager ID exists in our CTE. So let me give employees E, where E dot manager ID equal to CTE dot employee ID. And let's see that. Uh, where E dot manager ID equal to CT. What happened? Syntax error at or near. Select employee ID, employee name, manager ID, salary, 1 plus level from employees E, join CTE, where E dot manager ID, because we got the manager ID from here. equal to ct dot employee id. Let me check like what's the issue. Oh, we are doing the join, so the join should not take where, it should be on which column. So let's try that. Okay, now the issue is employee id is ambiguous because it get confused. You are populating the employee id from which table, employees table or employee id table. uh, we want, because we're doing the left join, right, and we want the employee from e dot employee id, e dot employee name, e dot manager id, e dot salary, one plus level as level. Let's run that. Now you could see for Bob and Charlie 2 and 3, you get the level as well, right? And we get the correct level. So if you see the diagram, Bob and Charlie on the level 2, and we already have the in CTE, in this CTE, if I execute this one, we already have the level for allies. But now in output, we have the, sorry, in the output, we have the level of only 2 and 3. But if I just do the union of the first one and this one, so basically if I do select star from CTE union all, then I will get the row from CTE and 2 and 3 from here. So you could see I get the output 1 2 2, and this is the only thing which I want. So for allies 1, Charlie 2, Bob 2. Okay, but we want for every employees Frank, David, Grace, Eva. So does it mean, because here earlier we created a simple table, uh, where we just populated the level for CEO, then we join with the employee table, and now we have this one, right? What next? Now you have the level for Bob and Charlie. If you have the level for Bob and Charlie, can you find the level for the other employees? So the answer is yes. So now you can rejoin. Now you can rejoin employees table. Employees table. Because for allies Bob Charlie we know, for David, what is the level of David? So what we will do? We will find the level of their manager too. And we already know the level of their manager, because level of their manager already know too. If we want to find the level of Eva, we want the level of their manager so that we can do plus one. If we want to do the want to know the level of Frank, we should know the level of their manager, which is 3. We know the level of their manager 3. So basically we can do the plus one. All right. So let's try that. Let's try it. So can we create a city of this table? So let's do that. So CTE one as, let's create a city. All right. Now, so this is my city E1. So if you see select star from city E1, this is the thing which I am telling you, uh, what initially come into your mind. All right. Though this is not a solution, but from here we are going to drive the solution. Okay. So this will, now you need to again join the employee table with this table, because now you have the level for Bob and Charlie, so that you can easily get the level for David, Eva, Frank, and Grace. All right. So let's do that. So select e dot e dot employee ID, e dot employee name, e dot manager ID, e dot salary. Basically, because I need every employee from the employees table in the output. For every employee I want to know the level, for every employee I want to know the team size, for every employee I want to know the budget, right? Okay. Even 1 plus level as level from employees e join. So instead of join city, now city one, because this is my city one. City one on e dot manager id. This manager id, because I want to join on this table 2 3, and e dot manager id is equal to cte dot cte1, basically cte1 dot employee id. So let's run that. You could see now you get the output for Bob, Charlie, David, Eva, Frank and Grace. The level is 3, but again we miss the alias. So same thing like earlier we did the union all, so we will do the again union all. So select star from cte, you can say one union all, and then run that. So you could see now we have the level for alias Bob. Even though we have the duplicate, which is totally fine because we are using union instead of union all. We are using union all instead of union. So duplicate is fine, that is we can handle, but you have the level, but still we don't have the level for 8, 9, 10. So what is the next step? Are we going to follow the same approach? Are we going to still again, because we what we can do is this is city 1. Are we going to create a city 2 as cte2 as now this is cte2? Now let's again join so that we can get the level for each and every. We can do that, but that is only going to work for this table. What about the other tables where we don't know the levels, where we don't know how many number of rows in that table? So basically this solution is we need something, some approach, some kind of a for loop, right? Some kind of for loop, some kind of recursion, some kind of iterative approach to solve this problem. Because if you figure it out, we are doing the same process again and again. We are doing the union role. We are doing the join of employee table with the CTE. We are creating a CTE, and then we are doing a join, and then we are doing a union role. Similarly, we created a CTE. We do the join. We do the union role. So basically, we and now if I want to find the level for 4, 6, 4 and 6, because 4 and 6 is here, because who is the sorry, for 8, 9, 10, for 8, 9, 10, who's the manager? 4, 6. And if I know the level for of 4 and 6, I can easily get the level for 8, 9, 10 by just adding one. So 4 and 6 I already know, so I can easily get the level for 8, 9, 10. But that is only going to work for this table. What about the other table? We don't know the maximum length, how many times we need to report. So they basically, this is not feasible solution, right? But same thing we need to approach. The only thing is we need to do a little modification. What is the modification is, instead of normal city, there is a concept called recursive city, right? So recursive city is means because we are unnecessarily repeating everything, right? So when as soon as you write the recursive keyword with CTE, what it will do is you don't need to write everything. It will automatically, like it will create a CTE, it will do the union all, and then it will run again, it will run again, it will run again, like uh, basically it will do like every uh, whatever we are writing here multiple times, it will do the run the for loop for you. All right. So how you are going to convert this statement, this, because this is easy, right? Anyone can write that, because we are not doing any like a complicated thing. We just populated one level because we know we need to populate the level. Okay. Then we thought, okay, how you get the level for the other is just 1 plus. Let's join that. Okay, now let's rejoin, right? But that is not feasible. So, and we know we should immediately, it should come into our mind, no, 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 there should be some kind of a for loop, there should be a kind of iterative approach, there's kind of recursive approach. So yes, there is a concept called recursive. So we just have to write here keyword recursive. As soon as you write the keyword recursivity, it will become recursive. So now when we are saying it is a recursive, so shall we mention all these things, whatever we already mentioned? Why should I mention again this? All right. Because if it is recursive, then this will be repeated again and again and again. Whatever the new city will be created, the new city will become here and it will again join here, like, which basically means I don't need to, when I mention recursive, I should not write this. So there is a syntax of recursive. We have a base statement. We need to write a base statement. After a base statement, we need to write a union, and then like whatever the statement we want to re-execute. So this is the join condition we are re-executing again and again and again, and this is our base statement. All right. So very little modification we will do from here. So this is a base statement, recursive city, and that will be a complete city, a recursive city. So right, so we write a base statement because recursive city normal city contains, like when we write normal city, this is working fine. Recursive city has the base statement, union all, and the actual join statement. So basically three things. And so the base statement, right? And we are ending the city, which is wrong because recursive city consists of multiple things. Base statement. And what's next? It's union all. So let's remove that union all. Then the join condition. Then join condition. So let's remove this. All right, 1 second. Just give me 1 minute. I will be back 1 second. Okay, so earlier we are repeating these join condition multiple times, right? uh, which you can do if you have to do only for the one table, and you know the, okay, it's very small table and just 10 employees, just write that query. You can manually hard code everything, right? But if the multiple examples, you don't know the length of the table, and even the length is very big, then that is not going to work because you don't know how many number of times you are going to write the journal. So basically, we will run some kind of for loop recursive, and for recursive, the base condition union all, because everything just is same. I just remove the below one, and now this will be city. So if I do select star from city, let's run that because I am saying it's recursive. So will it going to find a level for my every employee? So the answer is yes. So you could see it find the level for me. So you could see the answer is correct. 122, 122, 333, 444, 444. Now, just by writing this condition, I am able to find the level. So we are able to achieve the first solution. Right. So that is done. Now let's find the second one, team size. So you need to find a, for each employee who is a manager, count the total number of employees under them, direct or indirect. Basically, they said, okay, for LIs, for LICO, how many number of employees work under them? Maybe from the table you can say, okay, for who is the manager, like employee, maybe only two. No, they mention either direct or indirect. Bob and Charlie are the direct, but all the remaining are the indirect. So the direct one you can easily calculate. Bob and Charlie you can easily calculate, right? But how you are going to calculate the indirect, right? So basically, what we need is, we need a table. We need a table because count is different thing. You can simply run a count query, but before count, we should have a kind of a table, in a mapping table, where we have like employee, like Alice, and with Alice in front of Bob, then Alice, then Charlie, Alice, David, Alice, Eva, basically all the direct and indirect employee. Then I can just simply group by employee name or group by employee ID, right? To get the count. Um, Count is very easy because you have to do the count. But before doing the count, you need a you need a mapping. You need a mapping, right? So how you are going to do a mapping? So before directly jumping into a solution, we will follow the naive approach. Like what comes into, so let me hide this. Let me comment this because that part is done. That part is done, right? We can reuse anytime. But now the second part, because this part is only solving our level problem. This part is not solving our team size or budget problem. So we anyhow use this table, but we will use later on because we already solved this. But let's solve the second one. So for the second one, as I told you, I need a table where I want in one table manager ID, in another table basically another column the employee. So how can I do that? Can I can I do the basically join, self join, because for one, if I do the join with this column manager id, Alice will come here and the Bob and Charlie will come here. All right. Similarly, for Bob and Charlie, the David and Eva will come here. So let's try that, because to find the at least the direct employee. Forget about the indirect employees. All right. At least the direct employee, there is one table. You have to do the self join kind of thing. All right. Okay, let's try the naive approach. Simple simple join, which we just implemented for the level as well. Okay, so what we need select. We need because for every employee I want the employees who work under them. Like for Alice is also employee, right? CEO is also employee, but what are the other employees who work under them, right? So select employee ID. Like what I basically want, I need a table kind of thing. Like I need this table employee ID, and you can say subordinate employees, some kind of thing. Subordinate employee ID. What are the employees who work under them? So a kind of a mapping like Alice. So Alice, Bob, uh, Alice, Charlie, basically a kind of mapping. What are the all the employees who work under allies, right? So and for that we need to do the self join. So for employee id, and this employee id, because they are, even though these are the employees, but these can be manager or this can be manager, because the as I told you, I need a mapping called employee id and subordinate id, some kind of thing. So I will give as a manager ID, but don't get confused with this manager ID and this manager ID. Basically, I need a simple mapping, right? Okay, what's next? I need another ID, all right? So employee name as manager name. I am assuming all are manager, but who work under them? Maybe for under some manager, no one works because they are only a employee, right? So manager name. Okay, now what next? So we need to self join, right? We need to self join. uh, Manager id, manager name from employees, you can say m, because we need to do a self join. The first table is called as a manager, another table is called as a you can say employee table. So we are doing to self join from employees join employee. Either you can give e1 e2, it's totally fine. Let me give e1 e2. If you give M and E, then you can say, okay, from manager table we are getting a manager, from employee table we are getting an employees. So that's why I just give like M and E. Okay, from like, there should be some condition like join on which condition? Join on from even, from this table, from even dot employee ID, even dot employee ID equal to sorry, uh, from manager table you will get a from employee table you will get a manager id, and from employee table you will basically you need to join these two columns, manager id and the employee id, to be honest. And if you are for for every employee, right, for every employee I want to find the uh, who is the employee work under them. All right, so as an example, for bob I want to find. So what is my output? What I want is manager id, manager name, employee id, employee name, some kind of like mapping this. And if the manager ID will be 2, manager name will be uh, Bob, or if who work under like Bob, David and Eva. So the David ID is 4, and his name is David. So let me show you what I want. 2 and Bob and 5 and Eva. Because we want to get the team size so that I can do the group by manager ID and I can get the count. I kind of this kind of mapping. So from for each employee from manager table, right? So from manager table, I need employee ID because this manager ID is coming from this table from employee ID, and this manager name is coming from this table manager name. Okay, and then I need uh, employee ID. Employee will come from this table, right? So employee ID. So E from E table, E dot E dot employee ID as, you can say, subordinate ID. This could be subordinate ID, subordinate name. Okay, now E dot employee name as subordinate name from employees M. This is the manager M, and where M dot employee ID, because because this is a M table, M dot employee ID is equal to E dot uh, E dot manager ID. Let me run that. Sorry, I need to remove this one. Let me run that. Okay, so we found something. We found for because I need a mapping, right? Because if I have the table who work under allies, that will be easy. So for under allies, Bob and Charlie work. Bob and Charlie work. For under Bob, David and Eva work. For under Charlie, uh, Charlie's the Grace and Frank work. Grace and Frank work. Under David, Hank work. Under Frank, Judy work. Under Frank, Eva work. But I need for all the employees. The other employees are not coming anyhow. All right. But we want something. But we by this join we are only getting the direct employees. We are not getting the indirect employees. So how you get that? Because under allies we know Charlie and Bob work, but who work under the Charlie? Who work under the Charlie? So which means I can create a CTE with CTE as so this is my one CTE which is going to give me the direct employee. Select star from CTE. This give me the direct employee. This give me the direct employee. But if I want to get the indirect employee, then I will treat Bob and Charlie as a manager, and for Bob and Charlie, I will found a who will work under them. Basically, I will perform the same operation again. But now by joining this table, which will be my manager table, and the manager ID is, sorry, employee ID is like this table, because I want to find the who will work under like Bob. Bob ID is 2. Who will work under Charlie? Now Bob is manager, Charlie is a manager. A kind of thing like Bob is a manager, Charlie is a manager, right? And similarly, who will work under Eva? Who will work under five? And how I going to know if I like join with this table? If I join with this table, Bob ID is 2. Who will work under like 2? David and Eva. So the David and Eva will also come. All right, I can easily populate. So let's try that. So basically we have a one city. Now I will rejoin with this employee table. So how you are going to join? So select. You need manager ID, because we need all the same thing. We need manager name. We need uh, employee ID as subordinate ID, or even you don't need to mention subordinate ID. You can mention employee ID, employee name, who work under that. Right. Let me remove that subordinate ID, unnecessary, or let run that. Fine. Employee ID as subordinate ID, and employee name as subordinate name. I will populate from which table it will come here, right? But uh, from which table? From employees table, and from employees table, and we need to join here. Employees table, here we join basically both, because initially we have only both tables, and now we need to join. Sorry, uh, from from city, this from city, join employees table, and we can give employees table as e. On 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 which condition? On. Now we need to map subordinate ID, because this subordinate ID is considering as a manager, right? So subordinate is coming from CTE. On E dot subordinate ID is equal to, sorry, this is not E, this is CTE. CTE dot subordinate ID, E dot this subordinate ID is going to match with this manager ID, E dot manager ID. Okay, so we have like joined that. Now the only problem is this manager ID is come from like which table, and the other will come from like which table. So this manager ID, 1 second, manager ID, manager name, employee ID, as subordinate ID, employee ID. So this is fine. If you are going to run this will give you ambiguous error, because it get confused, because manager ID is here as well, and manager ID is here as well. It from which column you want. So I want manager ID from my city table, right? From my city table, city dot manager, and manager name, because we are finding the employees for the Bob and Eva city, and E dot employee ID and E dot employee name. Let's do that. Okay, let's see. Okay, now you could see for allies. Now we have four people: David, Eva, Frank, Grace. For Bob, we have Hank. For Charlie, Judy. For Charlie, Eva. And if you see, for allies, we have Bob, Charlie, David, Eva. Because I need to create a complete mapping. I already got four one. For allies, 1 second, something is wrong. For ally, okay, that is fine. But my earlier table is not coming, so I will do the union one as well. Select star from CTE1 union all, was only the join is coming, but the other thing is not coming. CTE, sorry. Now you could see my everything is coming. Not everything, only for so allies. For allies, who is the employee? Bob and Charlie. Bob and Charlie. And under the allies, under the allies, David, Eva, Frank, and Grace also work. Under the allies, David, Eva, Frank, and Grace also work. But under the allies, Hank, Eva, and Judy also work. Under the allies, Hank, Eva, but we don't have the Hank, Eva. So now, which means I will again create a city. Now I want who will work under 4, 5, 6, and 7. 4, 5, 6, and 7. So now these will act as a manager. For this manager, I will join with this table. So you could see we are unnecessary repeating same and same thing again and again, because if I have to do again, I need to repeat everything same again and again. And once I will basically perform the same join, I will create a city. Basically, this will be a city E1 as this will be a city. Select star from city E1. This will be a city. What happened? Comma. Right. So now this will be a city. Yeah. So this will be a city E1. Now I will join this city E1 back again with the employee table, and then again I will do the union operation. Again I will do the union operation. So you could see this is not a feasible solution, because anyhow for this table we will get, because this table gets like finished here, because 4 5 6 and 7, and but if we have more employees under 8, more employees under 9, more employees under 10, then are we going to again create a city and again going to join with the original table to find the who work under them? That is not going to work, right, to be honest. So you need some kind of a loop condition, and looping means recursion, iteration, some kind of iteration, so that I should not repeat all this thing again and again, which means I need to use the recursive CTE, right? And for recursive CTE, I need a base condition. I need a base condition. First, I need a base condition. Then I will do the basically union all, and I will perform a join. So, what is my base condition? So this is a join. This is join. This is not my base condition. But then again, union all, and then join. So the base condition will be, I will select the manager ID. I will select a manager ID. I will select a employee ID. All right, employee ID. I will select the employee name. I will select a salary as well. We also need a salary. We can also populate a salary, because that is anyhow will be required in my third condition for salary. So let's populate that salary as well. So I need a salary as subordinate salary. I am giving just a name. If you don't want to give any name, it's totally fine. From employees, from employees, where manager ID is not null. Basically for all the employees, so that it will be easy for me. Okay, and then I will do the union all, because as I told you, when you do the recursive city, there is a base condition, there is a union rule, and after the union rule, you need to perform a joint condition. So recursive city, I will give city 1, because this is already my city, and anyhow I have to uncomment this later on. So this is my city 1, and union rule from city 1 dot manager ID. And if you want a manager name, you can populate that. Let me populate that manager name as well. Okay, so ct dot manager name, e dot employee id as subordinate id, e dot employee name as subordinate name, from like cte join employees e on cte from cte1, not cte, and this will be cte1 on cte1 dot subordinate e dot manager id. Let's run that. Okay, manager name does not exist. uh, it's basically employee name only. Let's remove the manager name anyhow. We don't need. Let me run that. Okay, union query must have the same number of column. Okay, we should populate the salary here as well. E dot salary as subordinate salary. Okay, now you could see for allies, where is allies? Allies is one. Bob and Charlie. For allies, Eva, David, Grace, Frank. For allies, Hank, Judy, and Eva also come now. For allies, Hank, Evie, and Judy also come now, right? So basically, instead of writing multiple city again and again and again and again, infinite times, even we don't know how many times we need to write, we will use the recursive city. That's it. So we use the recursive city. So now you have the all the employees who work under allies. You have all the employees who have the salary. Now it's very easy because what you need now, you just need to do the group by. You have this condition recursive city, and I also like uncomment this one as well. I can also uncomment this one because I need a level as well, right? And I can remove this city, and now I have to remove this with recursive keyword because this is a recursive, so this is also a recursive. And here comma, let me rerun again if everything's work fine. Yes, everything work fine. Okay, so you have this table, one city is this which we are currently not using, where we have the level. This is city e1 from where we are populating subordinate salary. Okay, but next, now you need to calculate the team size. That is very easy, right? You can just do the group by manager ID for each employee. How many number of like people work, right? So let me run that. And similarly for like salary as well, you can simply like group by salary as well, right? Now you can do select. You have to do select manager ID. You have to select the manager ID because for every employee, uh, for one, how many team, what is the team size for one, what is the total salary of their employee, because these are the subordinate. Currently this is the subordinate salary, not the manager itself salary, because under the salary we need to calculate the salary of their own salary. That is totally fine, we will just do some addition later on. All right, but as of now, uh, select manager ID. And how you are going to calculate that team size, using count operation, count of subordinate ID or simple count star, right? As team size, as team size. Okay, sum of subordinate salary, subordinate salary, as you can say total salary, total subordinate salary, total subordinate salary. ठीक है? And from which table? From CTE1 table, because this is CTE1 table, right? Group by manager ID. Let me run that. You could see for one, 9 employees. If you go here for one, what is the team size? Nine. For three, team size four. Team size four. For two, team size three. For two, team size three. For four, 162, and 6241. And for the remaining, it's zero. It's not coming here, but we will handle. But anyhow, you have the something with you. So because we need to, because this is only giving you the team size, this is only giving you the supported salary, this is not giving you the level, because level is in my this city E, right? Level is in this city E. And the other employees, because I want to populate for the other employee, doesn't matter whether the team size is zero or not. uh, I need to populate the other employees. So I just need to join this table with my city, and I will do the left join so that all the employees will come from my left, which is my initial. If I show you, uh, select. Okay, this is a recursive city, so this is not going to work. Basically, from the city where we have the level populated earlier, so we will get the level from this city, and we will do the left join operation so that all the employees will come here. Then we will do the 1 second, we will join with this table so that the team size is populated. Here we have the subordinate salary, but we need a total salary of employee plus subordinate salary, so salary is also here. So we will just add the salary plus total subordinate salary, and that's it. Our query will get completed. So we have to create a cte. So let's create a cte with cte3 as, not with cte3, cte3 as. All right, and let's put comma here. Let's so select star from city E3. Okay, now what next? So this is city E3. You need to join. So you because let's see the output. What we need in the output. We need employee ID. So let me first populate employee ID. We need employee name. We need a level. We need team size. We need budget, right? Right, we need a budget. From from which table? From city table. From, because most of the things will coming from the left. From city join, not join, because left join, because we need all the employees. Currently this has very less number of employees, so that we are putting this in the left. If you want to do the right join, you could put it into right. So left join, on which table? On cte3 table, right? Because this is my city, city 3, city, oh, why city 3? I can give city 2 as well, right? City 2, left join city 2. On on which column? So basically on this column, manager ID, right? So on city dot employee ID, from there for all the employees, equal to cte 2 dot manager ID, right? And if you see, they have also told you you need to uh, order the result in ascending order by level. So let's add that as well. Order by, so city this one, right? We will do the join order by level, which is ascending, and budget by descending, right? Budget budget by descending, and employee name in ascending, employee name as ascending. Okay, but when we are joining these two table, from which table it is? This employee ID is coming from city table, employee name is coming from city table, level is coming from city table, team size is coming from city 2 table, all right? City table, and this is the budget. Budget is basically cte dot salary plus cte2 dot total budget salary, right? Total subordinate salary as budget. This is also not complete solution. I will show you as budget, and let me run that if anything left. Yeah. So you could see we got most of the thing, but still little things left. What are those little things left? I will show you. For allies, for allies. Let me see that. For allies 1984500. 3 Charlie 2441500. 2 Bob 2331000. Then 6 Frank David 23000. 13500. And Eva 307500. uh, 075. So here we are not getting the total, and we are also, instead of the zero, we are getting the null. So why we are getting that? So here when we see the team size, when you are joining these two tables in the city 3, we have only few like employees, right? But if we don't found the entry, we need to populate with 0. So we will use coalesce keyword, which is going to populate the first non-null value as team site. Let me run that. What happened? COAL. So okay, spelling is wrong. Now you could see this 00 and 00 populating. We have fixed that, but now we need to fix this as well, salary. And why this is not working? Because here we are saying CTE2 dot salary plus subordinate salary. Subordinate salary for subordinates are like for this employee Eva, they're not subordinate. So you are adding salary plus null, which is giving you the null, right? So you need to do the same thing here. Basically, if it is null, you will do the call less. If it is null, it will give you the 0. So then at least you are going to populate this salary. And city dot salary dot 0. What happened? Syntax error. Why syntax error? Team sites CTE dot salary plus CTE2 dot subordinate salary. By default, we are populating at 0 as budget. If I remove this, why it is giving me the syntax errors? Did I put something wrong? Uh, COALESCE, 0. Yeah, I'm not sure like what was why it was wrong. Now you could see our solution is working. Now just copy paste this query. Just copy paste this query and run here. Let's run that. Let's submit that. Okay, sample test case is working. Let's try to see if all the tests works or not. So you could see all the tests are working. To be honest, don't worry about, oh no, your query is not very efficient because you only beat 7% of the people. This is not something, because if you rerun, maybe it will increase, it will down, or maybe it will like jump from 7 to see from 7 to 75. I am running the same query. How it come from 7 to 75? So it is basically a backend compiler, how it is performing, but it really doesn't matter. All right. So that's the end of the video. So this is a very long video, I know, but if I directly jump into the recursive solution, may or may not be you will able to understand. That's why what I did is I starting with the basic, because recursive will not directly come into the mind, and we are not going to cram the solutions. So what we will do? Okay, we have to populate the level for at least whose manager ID is null. that is one level, we know we are going to complete that. Then we join that, then again we join that, then again we join that, then we feel okay, how many number of join we are going to do, that is not feasible. Then immediately come into our mind, okay, some kind of recursion approach we need, so we use the recursive solution. Okay, same thing we did for here, because to get a total set, to get a total number of employee, we kind of a mapping, side by side mapping. Okay, under ls how many number of employee work, under charlie how many number of employees work. So we did some join, but when we did the join, only the direct employee come, not the indirect. Then we do the again join, then again one more level come, then we do the again join, then again one level come. Basically we are repeating the same query again and again and again. That is also not feasible. So we immediately come, okay, which means that should also be the recursive. So recursive means the base condition and union all and the join condition. Similarly, the base condition, union all and the join condition. And as soon as you get that mapping, it's very easy, because after that we just need to do the group by, because we need the total size. Okay, let's do the count. We need the salary, let's count the salary. And in the salary we need to count their own salary, so let's count the old salary. And then we found that okay, because some fields are populating null, because that value is not there. Okay, so we will do the coalesce function to define the first non-null value, and non-null, if it is null, the first non-null value is 0. So we basically handle that. And after that they said okay, please order your result in this level, so we have ordered that in that level. So that's it. That's the end of the video. You can also give a try, and thank you.